Well, welcome back. In this lesson, we are going to talk about rhombuses, rectangles, and squares. And we're going to focus in specifically on telling whether a parallelogram is either a rhombus or a rectangle. We have three quick theorems that we will be using in this section. And the first theorem says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So as long as we have perpendicular diagonals, that creates a rhombus. And the second theorem says if one of the diagonals of the parallelogram bisects a pair of opposite angles, then the parallelogram is also a rhombus. So as long as angles 1 and 2 are congruent and 3 and 4 are congruent, then we also have a rhombus. And our third theorem says, excuse me, if we have a parallelogram and those diagonals are congruent, they're equal in length, in that case we have a rectangle. So here's a couple of problems, and it says, can you conclude that the parallelogram is a rhombus, a rectangle, or a square? Well, in letter A, the diagonal is bisecting the opposite angles, so these two are congruent and these two are congruent. So in this case, yes, we can conclude that this is a rhombus because the diagonals are bisecting the opposite angles. In letter B, excuse me, in letter B we have our diagonals are bisecting each other, but they are also perpendicular to each other. So since they are perpendicular to each other, they are that indicates that it's not only a parallelogram, but it is also a rhombus because they're perpendicular. And because they are congruent, it creates a square, excuse me. So by theorem 618, that tells us the diagonals are congruent, and that gives us a rectangle. The diagonals are perpendicular, so we know it's a rhombus, and anything that's a rhombus and a rectangle is a square. So in our got it, letter A says, a parallelogram has angle measures 20, 160, 20, and 160. Can you conclude that it is a rhombus, a rectangle, or a square? Well, we know it's a parallelogram. There are no 90-degree angles, so we know it's not a rectangle or square. So it is possible that it could be a rhombus. So in this case, we're going to say that one could be a rhombus. How about letter B? It says, suppose the diagonals of a quadrilateral bisect each other. Can you conclude that it is a rhombus, a rectangle, or a square? Well, in this case, we can't conclude any of those. We only know that it is a parallelogram because by the definition of a parallelogram, the diagonals bisect each other. Problem number 2 says, for what value of x is parallelogram ABCD a rhombus? Well, remember, the theorem says that the diagonal of the parallelogram must bisect the angle to be a rhombus, so we would have to set these two equal to each other. So we would get angle ABD would be congruent to angle CBD, and then substitute the algebraic expressions. 6x minus 2 equals 4x plus 8, and then solving that for x, we get x equal to 5. Here's one for you to try. For what value of y is parallelogram DEFG a rectangle? Go ahead and pause the video and see if you can come up with the answer to that one on your own. All right, I hope you gave that a try. The conditions that must be true in order for this to be a rectangle, remember a rectangle says that the diagonals are congruent. So we need EG to be congruent to FG, and we already know that diagonals bisect each other in a parallelogram. So we would need 2 times each of those, twice 5y plus 3, so this diagonal would be equal to twice this diagonal. But then if we divide by 2, that 2 goes away. So 5y plus 3 must equal 7y minus 5. And when we solve that for y, we get y is equal to 4. Here's a community service project. It says builders use properties of diagonals to square up rectangular shapes like building frames and playing field boundaries. Suppose you're on the volunteer building team at the right and you're helping to lay out a rectangular patio for a youth center. How can you use properties of diagonals to locate the 4 corners? Well, we have a couple of theorems that will help us. Theorem 618 says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So we would want these to be congruent in length, okay? So your string pieces would need to be the same length. Theorem 611 says if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So we would want these to be meeting at the midpoint. So to summarize this, your first step, you'd want to cut two pieces of rope for your diagonals, and you want them to be the same length. And then you would want those two pieces of rope to intersect at their midpoints. You want to join them at their midpoints, and then pull it tight, and the ends of the ropes will be the corners of your rectangle. Here is your lesson check. You've got 4 problems here. Please bring these completed problems to class, and we will see you next time.